Here we have x squared plus 4x plus 1 is equal to 0. The completed square form for x squared plus 4x plus 1 is x plus 2 all squared, take away 3. So we could rewrite the equation as x plus 2 all squared take away 3 is equal to 0. So we've replaced this with the completed square form. If we add 3 to both sides of this equation, we have x plus 2 all squared is equal to 3. Square rooting both sides gives x plus 2 is equal to plus or minus the square root of 3. Note that the square root of 3 times the square root of 3 is equal to 3, and that minus root 3 times minus root 3 would also be 3. A minus times a minus gives us a plus. Now subtracting 2 from both sides, we get x is equal to minus 2 plus or minus root 3. This gives us two solutions. We have minus 2 plus the root 3, and we have minus 2 take root 3. Using the calculator, this gives us minus 0.268 and minus 3.73, giving answers to 3 significant figures. Now consider x squared minus 6x plus 10 is 0. Once again we have the completed square form. So we could write the equation as x minus 3 all squared plus 1 is equal to 0. Subtract 1 from both sides, and we have x minus 3 all squared is equal to minus 1. But we can see here that this simply won't work. X minus 3 all squared, being a squared number, must be positive or 0. It cannot possibly be negative. So clearly there are no solutions, since there is no value of x which could make x minus 3 all squared be equal to minus 1. We've now met y equals x squared minus 6x plus 10 in a few of our videos. We've seen the completed square form, and we know this gives the minimum value as 3, 1. If we draw a sketch of the curve, the minimum point here is at 3, 1, which means the curve is always above the x-axis. Remember, the solution to a quadratic equal to 0 gives the points of intersection of the curve with the x-axis, and there are no points of intersection here. Strictly speaking, I'm probably going beyond what you need to know in the examination. Nevertheless, you should try to understand some of these points.